For your kind introduction. Yeah, I'm Dr. Prashanth Shivappa, working as Assistant Professor of Chemistry in SVM Arts Science Commerce College, Electrochemical, Bagalkot District, India. So today's of my talk is about electrochemical sensing of mercury using nickel ferrite graphitic carbon nitride composite modified screen printed electrode as one-shot disposable sensor. So as we all know that our environment is getting polluted due to modernization and globalizations. So we are completely making the whole system, with a full of waste materials that might be including the plastics, and we are making the water level is the quality of the drinking level water is going to get decay day by day. So in order to quantify those the unwanted things, there are a few methods to be determined or need to be analyzed by using the various methods. If you see the impact of water pollution, so increased pollution levels of surface water and groundwater and decay of quality drinking water is going on like anything. So the majority of these causes of pollution, including the natural as well as anthropogenic. If you see the natural things, that is natural calamities, then volcanic eruption, followed by anthropogenic, that is urbanization, as I told you, industrialization. So because of these reasons, what happens, the content of the various analytes or the dangerous elements or some other things is going to get accumulated in the atmosphere. So majority of those things, if we consider, there are we can see with those metal ions, that is what we can see the major contents if you see in the atmosphere. So if you see particularly see the metal ions like lead, cadmium, mercury, and copper are highly toxic and non-degradable, which are widely distributed in nature. And if you see these things, if if it is going to accumulate in our body, means again we feel or we may get so many diseases. So if you see the majority of the toxicity, that is one is hearing loss, then kidney failure, hypertension, blood pressure, and many more. And if you see the sources of these heavy metal ions, that is mainly due to from metallurgy industry, electroplating industry, and paint and pigment fertilizers. So therefore, the presence of toxic metal ions, even at trace concentration, may pose negative impact on both mankind as well as aquatic systems. So in order to determine or analyze these toxic metal ions, we need to develop some methods. And if you see this slide, heavy metal contamination from its sources to final impact on human. So how actually this heavy metal ion contamination is going to take place means from corrosion of metallic pipes, then animal aquatic, then poor quality and yield of growth, the natural deposits and erosion. So because of these reasons, the heavy metal ions is going to get accumulated on the atmosphere. And if you see the threshold limit value of various metal ions like lead, cadmium, mercury, copper, and this is the threshold limit value that is has given by the World Health Organization as well as Control Pollution Control Board, Central Pollution Control Board. And if this 10 ppb of lead content, if it is beyond 10 ppb is there, means what happens? So we are going to get a severe effect to the human, both mankind as well as aquatic systems. And these are the various threshold limit values. So below which, if it is there, means that's fine. If it is above this level, means again we may feel severe toxicity. So that's why both the World Health Organization as well as Central Pollution Control Board has prescribed some value, that is threshold limit value. So below which only the content of these metal ions should be there in the water system, like that. So by looking all those things, one can understand that definitely there is an urgent need for this metal ion quantification. But at the same time, there are few traditional methods are there, that is optical methods like UV visible absorption spectrophotometry, then atomic absorption, then inductively coupled plasma mass spectrometry. So most of these methods are very common in nature, but the thing is they require sophisticated instruments, skilled personnel to operate the instruments, as well as difficult for routine use, and prolonged sample preparation procedures are required to perform this kind of experiments by using traditional methods. But at the same time, we can think that is there any alternative methods are there to determine these metal ions by using other than traditional methods? Yes, of course, we can say that that is electrochemical methods. So if we talk about the electrochemical methods or electrochemical sensors, so these sensors are very simple and cost effective, clean and green, and very selective and sensitive, mainly applicable to field analysis, and can detect up to femtomolar level concentration. So these are the advantages of the electrochemical methods or electrochemical sensor over the traditional methods. Before going to explain what exactly the work has been done, I would like to tell the principle of this, how exactly this electrochemical sensor is going to work out. So what we can see, this is what a potential stat. So in the potential stat, we can see the electrochemical cell. For electrochemical cell, we can see what calomel electrode, working electrode as well as reference electrode, and which is attached to the personal PC. So here in this electrochemical cell, we can see that this is the counter electrode, working electrode, reference electrode. This working electrode is mainly depending upon the glassy carbon electrode or carbon paste electrode or indium tin electrode or screen printed electrode, and upon which we can modify this electrode by using various substrates like single walled carbon nanotube, multi-walled carbon nanotube, graphene, quantum dot, then carbon nanotube, like a nano diamond. So these are the various modifying materials. So we can easily paste or drop cast upon the glassy carbon electrode, and which can be acted as working electrode. And this is the reference electrode that has AgAgCl as a common reference electrode. And if you see this counter electrode, probably it is a platinum electrode. And once if you put the analytes, say for example any analytes, if you are really interested to do analyze, so that will be detected by this working electrode, and that can be given by this potential stat, and we can see this some electrochemical voltammograms like this. And okay, fine. By using this cyclic voltammetry, we can see that whether the analyte is present or not. We can do qualitative study. If you want to do the quantitative study, that how much amount of the analyte is present, so that time we should go for an anodic stripping voltammetry. So what exactly happens in anodic stripping voltammetry means, so upon which this electrode, that is what working electrode, we are going to coat the modifier material will be there. So upon the modifier material, see targeted analyte will going to get adsorbed onto the electrode surface. And once if you apply the potential, what are the adsorbed analyte will be there, that is going to get dissolved once again. That will come to the bulk of the electrolytic solution. And how much of the bulk of the electrolytic analyte comes to the bulk of the electrolytic solution, so that much response, that is electrical signal, we can come to know that with increasing the concentration of the analytes, so we are going to get the electrical response by you can see this one, anodic stripping voltammetry. So this is the what the entire principle of the electrochemical workstation. Similarly, in this direction, so basically in this, as I told you, that the carbon can be used as a substrate material because of the wide structural diversity in its form and chemically inert in nature, good conductivity, wide potential window, then easy modification, then easy electrode fabrication, and as well as cost effective. So because of that reason, carbon will be using as a substrate material for the electrode fabrication. And this is how actually, as I told you, the selectivity can be achieved by functionalization and the chemical modification of the substrate surface. So basically we are doing the carbon substrate upon which we are going to use the modifier molecule. In the modifier molecule, we can see the functional groups, and this functional groups is responsible for targeting analyte. So how this is how actually this is adsorption, desorptions can be easily done by taking this modifier molecules. And how much amount of adsorb, dissolved, this can easily be referred or monitored or recorded by using the electrochemical workstation. Like this electrochemical response we're going to get. So in this direction, the modification can be done by using glassy carbon electrode. If you see the glassy carbon electrode, basically we are going to coat upon or drop cast upon the glassy carbon electrode like this, and we are going to keep it for some time, and this will become as a modified electrode, and we are going to work this as a working electrode for the sensing applications. So this is the basically the electrochemical cell. So basically you can find the presence of auxiliary electrode or Calomel electrode and the working reference electrode as well as the working electrode. And there will be nitrogen purging. There will be small hole will be there in the electrochemical cell. And once if you see whether the electrode material is conducting or not, we can easily check with the help of standard redox probe, that is ferroferricyanide reaction. So from it you can say that whether the electrode is conducting or not, like that. In this direction, we have synthesized one material in this present study. That is, we have synthesized the graphitic carbon nitride, nickel ferrite nanoparticle, as well as graphitic carbon nitride functionalized with the nickel ferrite nanoparticle. So this is how actually we have synthesized by using melamine. We have prepared the graphitic carbon nitride. Then we have used the nickel as well as iron sources. Then we maintained the pH. Then we added a glucose as a fuel. Then we have hydro combustion method has been carried out, then calcined for 500 degrees Celsius. We would be able to get the nickel ferrite. Once if we get the nickel ferrite, we have put it into the simple ultrasonication method by taking this graphitic carbon nitride. Then we have sonicated for 1 hour, and we got this modified material. This modified material we coated or drop casted upon the screen printed electrode, but not on the glassy carbon electrode. So this is the characterization of the prepared material, that is graphite carbon nitride, nickel ferrite nanoparticle, then nickel ferrite as well as graphite carbon nitride material FDR characterization. Then we have taken the XRD characterization, and it is well matching with the GSPS card number. So then we took the surface morphology of the graphite carbon nitride, nickel ferrite, as well as the nickel ferrite graphite carbon nitride, and we have taken the TM images of the nickel ferrite graphite carbon nanoparticle, and from this we can say that the nanoparticle size is about 50 nanometer in size. Once if we get this material, so then we have taken the screen printed electrode. As I told you that working electrode can be used anything, that is indium tin electrode, indium tin oxide, glassy carbon, carbon paste, screen printed, but we have taken screen printed electrode in this particular study because screen printed electrodes are very cost effective and portable and one-shot disposable and eco-friendly sensor. We no need much time to polish those electrodes, as like other electrodes we need much time to clean those electrodes, and it can be taken out to the respective places for on-site detection, and it is going to good reproducibility and requires only low sample required and less time consuming, as well as apply to a range of different sample matrices. So this is the speciality of screen printed electrodes. And these are the pictures that shows how one can fabricate this screen printed electrodes. But of course, these are the screen printed electrodes we have fabricated. Our collaborators have fabricated these electrodes. That is Professor Craigie Banks from Manchester Metropolitan University. We have taken the electrodes from them, and this is what actually the screen printed electrode exactly looks like. And the advantage of this electrode is that in one strip we can see the counter electrode, working electrode, as well as reference electrode. And the traditional method, we required 3 electrodes, that is separately, but in one strip we can see this one. All the 3 electrodes can be found, and it is a one-shot disposable sensor. We can take it, we can keep it in a small pocket, then we can go to the on-site, then we can analyze whatever the analytes we wish to determine. So this is the exact methodology to hold or to connect to the potential stat. And finally, we have taken that working electrode, that is screen printed electrode, in presence of the mercury. And in presence of mercury, we found very good response of this graphitic nitride carbon nickel screen printed electrode. So this clearly shows that the modified electrode has shown very good response towards the mercury. Then by using cyclic voltammetry, we performed this experiment in order to quantify this one. So we have done the anodic stripping voltammetry, as previously I told that how exactly this anodic stripping voltammetry works. So with the increasing concentration, the response has been increased of the mercury concentration from 10 to 100 ppb, and we got 2.35 ppb of limit of detection. It is well below the threshold limit value prescribed by the World Health Organization. So this clearly shows that the modified electrode which fabricated in our present study can be easily utilized for the existing sensors in the market. And before that, we have optimized various things with the pH, pre-concentration time with various electrolytes, and as well as the from deposition potential. By keeping all those constant, we have studied this kind of response in presence of mercury. Of course, not only mercury, we can take other analytes also other than mercury, that is lead, cadmium, as well as copper. And we have done the calibration plot under the optimized conditions. So we got 2.3 ppb in presence of 10 to 100 ppb of mercury. So again, we done with some interference study, as we know that before going to apply for particular application studies, we should check the selectivity of the modified electrode, whether the electrode is suitable for mercury or any other analytes which will be present in the samples. So we done with almost all cations as well as the anions. So the modified electrode did not interfere with these ions. So we can say that the modified electrode is working very selectively towards the mercury. And we did some application study that by taking the tap water as well as industrial water and lake water, then we taken the chrome plating, then textile industrial water. So then we found some originally present mercury like this. Then we have added some 13 nanomolar of the mercury, and we did some recovery studies. So by taking this modified electrode, we got a very good recovery amount of this mercury from 98 to 100.32% of this recovery study. So this is tell exactly that the modified electrode can be utilized for selectively for the sensing of this mercury ion which is present in the real sample matrices. And in conclusion, we can say that a simple and rapid strategy for the fabrication of composite material and showed a correlation coefficient 0.99, that is a good reproducible modified electrode, and achieved wide linearity and good analytical performance, and applied to real sample matrices and achieved good recovery. So this is what actually the entire the proposed research tells about. So thank you very much for kind attention for listening my talk. Thank you, Anand.
Thank you.